class of this chapter. Okay, so electrochemistry last class. So already we talked about many things about electrolysis. We talked about, okay, about molten electrolytes, about aqueous electrolytes, their SRP value, and we talked about Faraday's law. Okay, now Faraday's second law also we have discussed. I told you W by W1, E1 by E2. Okay. Whereas how to calculate W from the first law, I told you W means deposited. Okay, mass deposited or gas evolved, how much evolved in the electrode. That how to calculate, that equal to W is equal to Z into I into T, where Z is called equivalence. Okay, and I is current, T is time. Z you can write like that. Z you can write that molecular mass of the compound what you want to check, I into T divided by n factor into Faraday 96500. Okay, what is n factor? I told you how to calculate. Okay, n factor is nothing but in that reaction how much electrons involved. Sometimes metals, whatever the oxidation state change, n value. Okay, number of electrons changed. So this is the thing. I gave you this question that 108 gram of silver is deposited at cathode from AgNO3 solution, aqueous solution by a certain quantity of electricity. The volume of oxygen gas that produced at 273 Kelvin 1 bar pressure from water by same quantity of the electricity is. Okay, so what they gave W value of Ag. So 108 gram. Okay, and they are asking W of oxygen. Now, simple thing, W of Ag by E of Ag is equals to, W of O2 by E of O2. Yes or no? So, W of Ag is 108. Now, what is the E of Ag? Equivalent mass of Ag. We know Ag will give Ag plus, or from Ag plus we will get Ag. So, N value 1. And what is the atomic weight of Ag? 108. So, 108 divided by 1 equal to oxygen weight we need to calculate, W of O2 divided by W of O2 divided by E of O2. Now E of O2, this thing very important to calculate E of O2. Listen, in water to form oxygen, what is the reaction? You know, water, okay, water to form oxygen. What was the reaction? So from here water it will take electron or give electron. So the reaction, I told you to remember this reaction, very important. 2H2O will give 2A2 plus 4H plus, okay, sorry, 2H2O will give O2 plus 4H plus, 2H2O plus O2 plus 4H plus 4 electron. Yes or no? So what will be the E of O2? Oxygen mass is 32. And what is the N value? 4. So 32 by 4, 8. Clear? So W by O2, 8. So 8 gram. So 8 gram oxygen will deposit. Clear? Now volume they are asking. See, very important. Volume they are asking. So 8 gram oxygen means how much moles of oxygen? 8 by 32 moles of oxygen. How to get the volume at STP? This is STP condition. So 22.4. Yes or no? So this is 4 and this is 5.6. So 5.6 liter. Clear? See, 8 gram, 5.6 liter. Understood?
Yes,
So
sir.
this is how this kind of questions came in board exam also. Okay, so you have to do like that. Next, try this. Let's see who of can tell this.
Sir, option B.
Option B.
B, B.
Okay, ball.
18 kilogram.
Okay. Next, what about Aditya?
Sir, I only told answer.
What about Sarvesh? Tell.
Sir, doing
So what? A factory produces 40 kg of calcium in 2 hours by electrolysis. Okay. How much aluminum can be produced by the same current in 2 hours? How much aluminum? So simple thing. In case of calcium, N factor is 2. In case of aluminum, N factor is 3. Yes or no? So calcium, E of calcium is equals to 40 by 2, 20. And E of aluminum is how much?
9.
E of aluminum will be 9. Okay. So therefore, you can say that what 40 by 20 is equals to weight of aluminum by 9. Okay. So here you get 2. So weight of aluminum is equals to 80. Easy.
Yes, sir.
Next, try this.
Sir, is it option C?
Option C. Okay. What about Aditya?
Option.
So here what you can do 4.5 gram deposited. So 4.5 by aluminum is 9. Okay. Now equal to W of hydrogen divided by what is the hydrogen mass will be there? What is the hydrogen equivalent will be there? 2 is or no? 2 or 1 about it. 2 or 1. See hydrogen. Okay. So hydrogen from H plus I am getting hydrogen. So 2H plus 2 electron will give hydrogen gas. Yes or no? So 2 electron will be there. So 2 by 2 equal to 1. So E of hydrogen will be 1. So W of H2 will be half. So half gram of hydrogen gas means how much mole of hydrogen gas? 1 by 4 mole of hydrogen gas. So 1 by 4 into 22.4. So again 5.6 liter. Clear?
Yes,
See,
sir. Sir, how does it become 1/2 to 1/4?
see, hydrogen reaction is this now.
Oh, okay, sir.
So N value 2. Yes or no?
Yes, sir.
So N value 2 means E of hydrogen will become 2 by 2 is equals to 1. Okay. Then you calculate, you will get the answer. Then you calculate the moles. From moles, you have to calculate the volume. Okay.
Yes, sir.
Next, this will try later on homework. Next is next coming to conductance or conductivity. So yesterday last class also I told you that we know V is equals to IR, right? What is V? V is voltage, I is current, and R is resistance. What is resistance? Resistance means to stop the flow of current in a wire or in a electrical wire. How much, like a certain force is there, force is known as resistance. Okay, so that resistance depends upon rho L by A. What is rho? Rho is specific resistance or resistivity. What is L? L is the length of the wire and A is the area of cross section. Okay, A is the length of the wire, L is the length of the wire, and A is the area of cross section. Okay, and rho is, what is rho? Rho is nothing but specific resistance or resistivity. Now, what is the unit of resistance? Unit of resistance, you know, ohm. Okay, and let's suppose so we are calculating the unit of rho. Okay, so rho L by A, rho L by A. So L unit is meter and A unit meter square. Yes or no? So meter and meter square will cut. So rho unit will ohm meter inverse. Sorry, ohm per meter. Clear? Or ohm per centimeter. Remember one thing. One. Hello. Uh, no. Ohm meter. Ohm meter will come. Okay. Ohm meter will come. And we know that ohm 1 meter equal to 100. 1 meter is equals to 100 centimeter. So sometimes centimeter questions and given values in centimeter. So you have to convert that. Now coming to conductance. Conductance means what? The reverse of resistance. Resistance means to stop how much force is going on. Conductance means how much conducting it is. Okay, easily conductance it. So reverse. So how? So if you reverse, you will get 1 by rho into A by L. Okay, so 1 by rho known as kappa. Okay, so kappa is equals to kappa A by L. So conductance is equals to kappa A by L. So what is the unit of kappa? What is the unit of conductance? Conductance unit will be ohm inverse, or written like this ohm inverse, or written like this also mho. Okay, MHO, mho. Like ohm you write reversely mho, or in general SI unit is known as Siemens. Siemens or capital S. Okay, SI unit of conductance is Siemens. So Siemens is equals to kappa into A by L. Understood? Now kappa unit will be Siemens meter inverse. Yes or no? Now remember one thing: 1 meter inverse is equals to or 1 meter, 1 centimeter inverse equal to 1 centimeter inverse equal to 100 meter inverse. Reverse this thing. In this case, reverse will. Okay. So 1 meter inverse is equals to, we can write 10 power minus 2 centimeter inverse. Okay. 1 meter inverse equal to 10 power minus 2 centimeter. Whereas 1 meter equal to 100 centimeter. That kind of unit conversion you need to understood properly. So this is conductivity. Conductivity or known as specific conductance. Understood this thing? So how, if conductance value given, how to say, if specific conductance value given and A and L value given, you can easily calculate the conductance. Okay. And and the specific, see, every wire or every cell you are taking, conductance value will differ. Okay, but specific conductance value will same. That we will talk about specific conductance more. Now talking about conductivity or specific conductance, denoted as kappa. What is conductivity? Simple thing, understood. G is equals to kappa into A by L. Yes or no? If I take A is equals to 1 meter square or 1 centimeter square, 1 meter square or 1 centimeter square, and L is equals to 1 centimeter, then G is equals to K. Okay, G is equals to kappa. What does it mean? Like if you take 1 centimeter square a tube, okay, and you put the electrode 1 centimeter apart from it, how much electricity will pass or how much conductance between these two? That is known as conductivity. Okay, so conductivity is nothing but a conductance, but in a specific conduct. condition. Understood? In a specific condition. So generally we are taking centimeter. Why we are taking centimeter? Because centimeter is a small unit. Meter cube is a very big unit, right? Meter cube is a very big unit. Also, you can tell that 1 centimeter square is the area and 1 centimeter is the length. So what will be the volume? 1 centimeter cube. So if you take a like box who have a volume 1 centimeter cube, and what is the potential difference or what is the conductance, that is known as conductivity. Okay. Now why you are taking in centimeter? Because 1 meter cube is a very big. Okay. 1 centimeter cube means what? 1 ml. 1 ml. Whereas 1 meter cube means 1,000 liter. 1,000 liter means your home using that in your house there water tanks are there. They are nothing but 1,000 liter. Whereas 1 ml you know how much. Okay, so that much called is conductivity. So questions will come that what is conductivity, what is conductance and all. Okay. Also, I sent some questions regarding liquid solution. Have you gone through it? I'll take a test next week. I'll take a test liquid solution and electrochemistry both. So you have to prepare. Today I'll send the electrochemistry questions also, like that questions. Okay, you have to prepare for that. Any doubt you can ask me. Okay. Next, next is G is equals to K into A by L. Okay, if you rearrange, G is equals to L by A. Yes or no? K is equals to G into L by A. Remember, this L by A is known as cell constant. Cell constant. L by A known as cell constant. Every different cell having this cell constant value different. Okay. Every different cell having this cell constant value different, and cell constant unit meter inverse. Okay. Cell constant unit meter inverse. Okay. It is also denoted as G no G star. Okay. So kappa is equals to, we can write G into G star. Understood? Okay, so
Yes, sir.
depending on the value of kappa, if the kappa value is very high, then it is highly conductive. A conductor, if medium and all, it depends, it will tell semiconductor. If it is very low, zero also, that is known as insulator. Okay, depending on that, we will say that which is conductor and semiconductor or insulator. And in any battery, this value written, this kappa value written, G value will not written, kappa value written. Every battery you check generally that batteries will written kappa value, not G value. Next, see like this here, you can see this is metals. Okay, sodium metal. These are the kappa values. So see, kappa values are very high. Whereas graphite is a conductor. Okay, graphite is a conductor. This 10 power 3, whereas this is only 12. Okay, here 1,000. Iron also 1,000. Highest is sodium. Sorry, highest you can see silver. Silver is the highest electrical conductor. So here you can see the kappa value 6.2 into 10 power 3. 62,000. 6,200. Okay. Whereas graphite conductivity, you see this. Okay. Now coming to copper, almost close. So that's why we are using copper. Okay, somewhere we are using, so gold also using, gold we are not using. Okay, iron we can use, like in railways iron we are using, aluminum we are using. Okay, now in aqua solution you can see, aqua solution pure water will not show any electricity, 10 power minus 5, very small. Whereas HCl, it will show electricity. KCl, it will show little bit small. So here how to identify it, understood. HCl is a strong acid and containing what ion? H plus and Cl minus. Whereas KCl is a weak acid, salt. Whereas what ion it is having? K plus Cl minus. Now tell me, both having Cl minus ion, it's okay. But what is the difference? H plus and K plus. Which is higher in size? Obviously K plus higher in size. So higher in size means it will move very slow. Yes or no? So slow moving means
Yes.
less conductivity. Okay. Similarly here you can see Na plus. Na plus also will move slow. Why? Now you will tell, sir, Na plus is low, Na plus is low, sorry, low size than K plus. Why not it is moving fast? Remember, aqueous solution, 0.01 molar. Aqueous solution given. Okay, so aqueous solution, I told you, Na plus size will be more than K plus. Okay, in aqueous solution, Na plus size will be more than K plus. Whereas this is what? This is CH3, acetic acid, CH3, CO2, H. Weak acid. Weak acid means concentration of H plus is very low. So very low means conductivity also low. But if you dilute it, listen very carefully. See, weak acid you are diluting 0.1 to 0.01 dilute solution. If you dilute it, then you see the conductivity also decrease. Clear? If you
Yes,
dilute
sir.
it, conductivity decrease. Next, glass, see insulator, no conductivity. Okay, whereas semiconductor, copper oxide, silicon, they have the value like this. So to by using this, we can use this as a semiconductor also. Okay, as a electrical conductor also. Okay, so semiconductor have their own uses and all. Understood? So by conductivity value, we can check that which is conductor, which is semiconductor, insulator. Okay, understood? Any doubt?
Yes, I understood, sir.
Okay, so conductivity unit sometimes are Siemens meter inverse or ohm inverse meter inverse. Okay, clear? Sarvesh, response. I need response.
Sir.
Okay. Now, how to calculate, how to measure conductivity in iodic solution? Generally, it is not in your syllabus, but just remember how to measure. Like in your physics, you learn about I think so Wheatstone bridge. Okay, Wheatstone one kind of bridge is there where you can calculate the voltage of any system. Okay, if you just add the Wheatstone bridge, you can calculate the system voltage. So if you add this cell in that Wheatstone bridge, you can calculate the L by A value. There are some calculation, it is not in your syllabus actually. Okay, just remember how to calculate by adding Wheatstone bridge, and from that we can calculate. Okay, no need to remember like that all the things. Okay, now
Yes, sir.
this is very important, very important. See, molar conductivity of ionic solution. Now what is molar conductivity? Molar conductivity means that conductivity of 1 mole electrolyte. Conductivity of 1 mole electrolyte. So how to how to show it? Molar conductivity lambda m. Okay, molar conductivity, how to show? Lambda m. Now, what is the relation between lambda n and normal conductivity? What is the relation between lambda n and normal conductivity? Simple thing, that conductivity of 1 molar solution. Okay, conductivity of 1 molar solution. Now, this we are calculating in centimeter. Centimeter means ml. So we have to multiply with 1000, right? Yes or no? So simple formula, remember that lambda m is equals to kappa into 1000 divided by concentration. Okay, now concentration given in molarity. Clear? Clear or not?
Yes, sir.
So what is the unit of molarity? Molar conductivity? Centimeter. Centimeter. Okay. Conductivity unit. Sorry, conductivity unit Siemens centimeter inverse. Molar conductivity unit Siemens centimeter square mole inverse. How we are getting centimeter inverse into centimeter cube by mole per liter. So liter cut Siemens centimeter square by per mole. Remember this thing. Clear? Clear or not?
Yes, sir.
Now, feature of conductance. Remember, conductance is a additive property. And conductance additive property. Okay, whatever. Let's suppose I this pen having one conductance, my hand having one conductance. If I add, then you pass the electricity, conductance will add. Okay, additive property. Okay, so for aqueous solution containing several electrolyte means you add KCl, you add HCl. Okay, all of the conductance will added. Conductance added, not conductivity. I'm telling you, very important thing. Conductance will add, conductivity will not add. Conductivity is an intensive property. Okay, now generally G of water conductance we neglect it. Why? Very low. Yes or no? So every time we no need to add. So whatever the conductivity is showing of of a cell, of a electrolytic cell, that will be the conductivity equal to the conductivity of the ions. Okay, clear?
So can you repeat last
See,
question?
you have a electrolytic cell. Okay, electrodes are there. Now in this electrolytic cell, you have the solution KCl or NaCl.
Yes, sir.
So there water also there. Water also can show conductivity, but have a very low conductivity. Okay, have very low
Yes, sir.
conductivity.
Oh,
So water conductance we will not add in KCl conductance. Okay, just only
okay,
KCl
sir.
conductance. Okay, let's do one question. Tell resistance of a decimolar. Decimolar means, tell me, decimolar means how much molar? 0.1 molar. Okay, so resistance of decimolar solution between two electrons. This. Find out specific conductance. Tell.
One second.
Simple mathematics. You know the formula. Okay, you know the formula. G is equals to kappa into A by L. As a G means 1 by R. So kappa is equals to 1 by R into L by A. Yes or no? So 1 by R means 1 by 50 into L value. L value is, tell, L value given 0.02 and A value 0.004. Okay, 0. As a triple zero four, triple zero four. Okay,
Yes.
so if you calculate it, what will happen? Tell. See, 1 by 50 into 0.02 means 2 by 100, and this 4 into 10 to the power 4. Okay, so 100, this will become square 2, so 100. So 1 will come. Kappa will become 1. Understood? Kappa will become 1.
One.
Understood?
Yes, sir.
Yes. Answer will be. If they are asking molar conductance, then lambda m, then 1 into, see, already we are calculating in meter, so no need to multiply with 1000. So 1 by 0.1. Okay, so it will become 10 molar conductance. Understood?
Yes, sir.
Next question, right? Tell. Molar conductivity. Done. Hello.
One.
I know this much time taken, huh? I need just answer. I'm asking any explanation. Tell. Hmm?
I'm getting wrong answers.
Wrong answer. Easy question. So resistance given. Okay. See, whenever physical chemistry question given, na, write down all the data. Or physics also, write down all the data. R is equals to 0.2. Okay. Next, sorry, R is equals to 50. Okay, R is equals to 50. Concentration given 0.2 molar. The specific conductance of the solution given. So kappa given 1.4 Siemens meter inverse. The resistance of 0.5 molar solution of the same electrolyte is 280 ohm. Okay, 0.2 is given. Now resistance of the same electrolyte is 280 ohm. Molar conductivity of 0.5 molar solution of the electrolyte in 7 meter square mole inverse. Now tell me what you are doing. So this is given. Now they are telling that when concentration is 0.5 molar, the resistance is 50 mole. 50. Okay, clear or not?
Yes, sir.
Now what do you have to do? Tell. Anyhow,
Sir, not 52. Wait.
sorry, 280, right? So
Yes, sir.
you just first have to find out L by A value. Z star, yes or no? G star.
Yes,
So
sir.
G star will become 70 meter inverse. Okay, 70 meter inverse. So kappa equal to for 0.5 molar. Kappa will change for 0.5 molar solution. So kappa is equals to will come 0.25 into 10 power minus 2 or 0.25. Okay, clear or not? Hello,
Yes, sir.
clear? Now lambda m is equals to kappa into 1000 by molarity. That's it. Okay, remember kappa will change in every concentration. You have to calculate. Okay, you have to calculate. So for that you need the G star. So G star is equals to then you calculate the kappa value, new kappa value. Clear? Clear or not?
Yes, yes, sir.
Okay. Next. Tell. Tell. So answer will be Siemens meter square mole inverse constant of proportionality. Whatever proportional you are taking. Okay. See that well. Clear? Yes or no? Next. Tell. The molar conductivity given. You need to find out of a with electrolytic. No, no. Normal conductivity given. Molar conductivity you need to find out. Go ahead. Normal conductivity given. Molar conductivity you need to find out.
Option B.
Option B. So lambda
I
m is
just
equals to
11,
inverse.
11.52.
Huh. So 5.76 into 10 power minus 3 into 1000. Okay, divided by 0.5. Yes or no? So it will come
Yes.
around 10 or it's come around 11. So 11.52. Okay. So these questions you do. Next, whatever the effect of concentration on conductance and conductivity. Whatever the effect of conductance, these two are last topic. Okay. Effect of conductance. Already I told lambda m equal to K into V. Okay. V means concentration, right? See, lambda m is equals to K into 1000 by concentration. Understood? So if you increase concentration, so lambda m, if you increase concentration, lambda m will decrease. Yes or no? Lambda,
Yes, sir.
or if you decrease concentration, lambda m will increase. And
Yes, sir.
concentration increasing or decreasing means, if you decreasing concentration means dilution, right? Decreasing concentration means dilution. Increasing concentration means dilution will be low. Okay. So if you dilute any solution, concentration will decrease. So lambda m value will increase. Conductivity, molar conductivity will increase. Understood?
Yes, sir.
But conductivity, remember, conductivity always decrease with concentration. This thing very important. Okay, effect of concentration. Conductivity always decrease when concentration decrease, but molar conductivity reverse. Okay, molar conductivity
Yes.
reverse. Okay, now see, for normal salts, neutral salts, conductivity, molar conductivity decrease when you molar conductivity decrease when you dilute it. Okay, molar conductivity decrease when you more dilute it. What is this equation? This equation known as okay, this equation. Okay, by this equation you can calculate, like this is a straight line equation now. Y is equals to mx plus c. Yes or no? Where m
Yes.
is a here, but a is minus a, so the slope is negative slope. Slope is negative slope. So that's why molar conductivity of neutral salts will be decreased in a straight line. Neutral salt will be decreased in a straight line. Okay. So here now what is lambda not m? What is lambda not m? Lambda not m means, let's suppose your dilution is zero. Okay, sorry, dilution is high, concentration zero. Means too much you dilute it. The consent you molecule, the solution you dilute too much, then infinite, no interaction between any ions. Then what will happen? Your lambda m value also becomes zero. Yes or no? Your lambda m value also becomes zero. So that at infinite dilution, some value we will get, right? Some value we will get, and that will be the highest value. Okay, that will be the
Yes.
highest value. So every salt at infinite dilution have different values. Every salt at infinite dilution have different value, and that value is known as this. Is known as this. So what is this known as? This is known as lambda not m. Lambda not m is nothing but molar conductivity at infinite dilution or zero concentration. Okay, molar conductivity at infinite dilution or zero concentration. Okay, so at infinite dilution all will get some value for neutral electrolyte. Now coming to weak electrolytes. Okay, these are strong electrolyte, this is strong electrolyte, this is weak electrolyte. Weak electrolyte means it will not break properly. Like you take KCl or NaCl, if you take 100 molecule of KCl, it will break into 100 molecule of K plus and 100 molecule of 100 100 of K plus, 100 of Cl minus. That's why KCl known as strong electrolyte. But if you take acetic acid, CH3CO2H, 100 molecule if you take, suppose you will get 6 on 6 acetate ion and 6 H plus ion only. Understood? So it is not dissociate completely. That's why equilibrium sign is there. In grade 11, you learn in equilibrium this thing, ionic equilibrium, you learn this. Okay, so what happened here? What happened here? The graph changed. Why? Understood this graph properly. What happened? At infinite dilution, we can't tell what is the exact value of acetic acid, okay, or weak electrolyte. What is the exact value of weak electrolyte? It is high, it is very high, okay, but we cannot tell what is the value because it is not cutting this axis. There will be no value we will get, okay. And when you dilute it, after some dilution, when you dilute it, what happened? Am I audible? So when you dilute it, okay, so when you dilute it, it will be infinite solution. Now, when concentration increase, lambda m value will decrease. Now only I told, lambda m inversely proportional to concentration. So when concentration increase, lambda m decrease. Now why exponentially decrease? Understood this thing? Why exponentially decrease? Exponentially why decrease? Because when you increase the concentration, H plus concentration will decrease. Yes or no? In the solution, all the H plus concentration will interact with water. So the conductance will decrease exponentially more than strong electrolyte. Okay. What are the conclusion? Understood very clearly. Simple thing. By this graph, what are the conclusion? For strong electrolyte, there is a straight line and it is cutting this in y-axis. So for strong electrolyte, we will get a lambda m value at infinite dilution. That is known as lambda m naught. But for weak electrolyte, we cannot. So for them, we have to use one law called Kohlrausch law. Okay, for them, we have to use one law called Kohlrausch law. What is for weak electrolyte? What is the molar conductivity? Okay, so some questions you will do. Tell a graph was plotted between molar conductivity of various electrolytes. You have to say which one is this? 1, 2, and 3. Which one is what? So by simply you can say that this is weak and these two are strong. Yes or no? So out of NH4OH, so out of NH4OH, HCl and NaCl, NH4OH is the weak one, weak base, you know. NH4OH is the weak base. So if it is a weak base, 3 is NH4OH. So option C and option D wrong. Now coming to NaCl and HCl, who have more conductivity? NaCl and HCl, obviously HCl. So 1 is HCl, 2 is NaCl. Clear? Clear or not? Understood how to check that? Next, tell that in the various molar conductivity, what is this? For which it is? Acetic acid. Okay. Next, the equivalent conductance. Okay, lambda con m is equals to lambda infinity, then plus or minus b root c. Minus b root c, right? Yes or no? So answer is this. Okay, this equation known as d by Huckel-Onsager equation. Very important. D by Huckel-Onsager equation. By this, you can calculate any lambda naught value or lambda c value. Okay. Next, tell conductivity always increases with decrease in concentration of electrolyte. Conductivity always increases with decrease in concentration of electrolyte. Molar conductivity always increases with decrease in concentration of electrolyte. Tell. So answer B. Okay. Conductivity always increases with decrease in concentration. No, conductivity directly proportional to concentration. Molar conductivity inversely proportional to concentration. Okay. So B is right. Next, Kohlrausch law. What is Kohlrausch law? I told you for strong electrolyte you can calculate lambda m naught, but weak electrolyte we can't calculate. So that's why Kohlrausch give a law. What is Kohlrausch? Kohlrausch told that at infinite dilution, when the dissociation of electrolyte is complete, each ion makes definite contribution towards molar conductivity of electrolyte. Irrespective of the nature of the ion, it is associated. Means, let's suppose you are taking KCl, okay, and you are taking NaCl, okay. So you dilute it, you will get K plus also and Na plus also, and in this side you will get Cl minus, Cl minus. See, lambda m naught value of Cl minus will be same for both the cases. Understood? Understood this thing? Understood this thing? Yes or no? That if you are using KCl, if you are using NaCl, or if you are using CSCl, whatever you are using, this lambda naught value of Cl minus will be same for every cases. Okay, or if you are using positive side, let's suppose you are using Kf and you are using KCl, you are using KBr. All the three cases lambda naught value of K plus will be same. Understood? So, so yeah, see, this is the thing. Limiting molar conductivity of any electrolyte can be represented as a sum of the individual electrolyte. So I can tell lambda naught of NaCl is equals to lambda naught of Na plus lambda naught of Cl minus. Clear? Now lambda naught of K2SO4. Tell lambda naught of K2SO4. So 2 into lambda naught of K plus lambda naught of SO4 2 minus. Yes or no? Now think about one thing. By this we can calculate lambda naught M of CH3CO2H. How? See, if you have NaCl, okay, if you have lambda naught value of NaCl, and if you have lambda naught value of KCl or HCl, these are all strong, and lambda naught value of acetate CH3CON, this is also strong. Yes or no? This is also strong. So how to find out this? You can easily tell, sir, CH3 CONA plus HCl is equals to CH3CO2H plus NaCl. Yes or no? So CH3CONA means lambda of CH3CONA plus HCl, lambda of HCl minus of lambda of NaCl, minus of lambda of NaCl is equals to lambda of CH3CO2H. See, two method I will teach you. One, either you write the equation, you can get, or else what you can say, sir, I need lambda of CH3 CO minus plus lambda of H plus, right? Yes or no? So what I have Na plus, I have Cl minus, I have H plus, I have Cl minus, I have CH3 COO minus and Na plus. So what I have to do? I have to add these two. Yes or no? So I have to add these two and I have to subtract this one. Yes or no? I have to subtract this one because here Na plus you have to subtract and Cl minus you have to subtract. So like that, you have to add these two and subtract NaCl. Clear? So any value given, these values will be given. These values will be given. So how to calculate? Understood? Yes or no? Okay. So let's do some question. You will see like this. Okay. So let's do some question. You will understand. Tell which equation is incorrect.
Option B, sir.
Hmm? Option D. Anyone else?
B, sir.
So here what happened? KCl minus NaCl. So Cl and Cl will cut. So K minus Na. Here also K minus Na. So this is correctly given. Right? Yes or no? Here bromine and chlorine is there. Sorry, sodium cut. So bromine minus chlorine. Here potassium, bromine. This is also true. Here water. So we need to find 2H plus. Sorry, 2H plus OH minus actually. H plus OH minus. Water in case of water. So what is there? See, chlorine minus chlorine cut. Sodium minus sodium cut. So H plus OH minus. So this is also true. Now NaBr minus NaI. Br minus I. Br minus Na minus. So this is false. Understood? Simple question, simple. Okay, next. Tell. Do it. Let's see. You can do it.
Option C.
Option
C 120.
128. Okay, now see, check. So what I have to do? See, Na, this plus this minus this. Yes or no? So 126 plus 152 minus 150. So what will be there? 126 plus 2, 128. Okay. Now
Yes,
think
sir.
about one thing. How to cross check this? Cross check is there. See, Na, Br they are asking. So obviously it will be Br minus. Br minus in aqua solution will be smaller. Obviously more than NaCl, but not more than KBr. Right? KBr will be less. Yes or no? For NaBr will be lesser than KBr because KBr potassium is smaller than Na plus. Yes or no? So it is lesser than that. So correct answer will be 128. Okay. So you can cross check. Next. What about Sarvesh?
Sir, what is equation?
AC means AC means acetyl group. CH3 CO. This group is known as acetyl.
Like,
Acetyl. Okay. So CH3 COONA is known as NaOAC. NaOAC. Yes or no? AC. Similarly, ACOH means acetic acid. CH3 COOH. Clear? That's it. Go ahead. What additional value you require to find out this? Answer, answer. NaCl unit, right? Like Na and Cl you need to remove. So NaCl unit. Clear? Understood? Now, this lambda m value, we can calculate degree of dissociation. Like how the weak electrolyte or strong electrolyte will dissociate properly. So degree of dissociation in ionic equilibrium, you learn degree of dissociation, alpha value. Okay, so alpha is equals to that lambda m by infinite dilution lambda m naught. Okay, lambda m by infinite dilution lambda m. And from that you can calculate K equilibrium. So for acid, K equal to we know C alpha square by 1 minus alpha. Okay, C alpha square by 1 minus alpha. Also remember, concentration of H plus is equals to C alpha. Okay, so by that you can calculate pH also. pH equal to minus log of H plus. pH equal to minus log of H plus. So sometimes questions ask that calculate the pH if lambda m value is given and lambda m not value is given. So find out alpha first, then concentration, then pH. Okay, clear? Okay, next. Go ahead, tell. What is the degree of dissociation? Alpha value they are asking. Tell. Tell. What is the lambda m value? Lambda m value given 5 into 10 power minus 5. We need to find out lambda m naught. So how do you find out? See, they are asking HA. So HA means, how to find out HA? This plus this minus this. So 425.9 plus 100.5 minus 126.4. Yes or no? Yes or no? So this is equals to, we can write 525.4, sorry, 526.4 minus 126.4. So 526.4, so it is 400. So lambda naught 400. Okay, clear or not? So alpha is equals to, we know, 5 into 10 power minus 5 divided by 400. Okay, so if you calculate, I think something will become, some conductivity given, molar conductivity we have to calculate. Okay, conductivity given, K kappa value given. This is not lambda m. So lambda m is equals to kappa into 1000 by 0.001. Okay, but same will come, right? No, no, this 0.001. So it will become 10 power 6, right? So it will become 50. Okay, multiplied with 10 power 6. So it will become 50 divided by 400. So 1 by 8. 1 by is equals to 0.125. Clear? See, check. So first kappa value given. Okay, lambda m need to find out. Okay, okay, go ahead. Tell. Dissociation constant K, Ka value. K equal to C alpha square. Directly you can. Go ahead. Find out alpha, then C alpha square. Tell. Hello. C given m by 32, 1 by 32. Yes or no? 1 by 32 molar. C value. So 1 by 32 into 1 by 8 square. Okay. Sorry. 8 by 400, right? So 1 by 20 square, right? I will say. Whatever you will get actually. So 1 0 1 0 2. So that. Okay. Next. From KSP, this is not in your syllabus actually. Okay, KSP value calculation is not there. Now last topic, cells. See, remember there are whatever you are using cells in your daily life. Cell, two type of cells are there. One is primary cell, one is secondary cell. Secondary cell. Primary cell means one time use. One time use. You cannot recharge it. One time use. Like remote batteries, all are primary cell. Secondary cell means you can charge it. Okay, chargeable. Like your mobile battery are chargeable. Okay, so secondary cell. Now primary cell, there are different type of primary cell we learn. Secondary cell, different type of secondary cell we learn. One is, see, batteries. Cell means battery, right? Cell means what actually? This whole electrochemical reactions where it is going on, that is known as cell. Okay, so primary batteries means over a period of time a battery become dead and cannot be reused again. Okay, example, dry cell, mercury cell, button cell. You know, when your child, some phone you are using that have small button type of cell. Okay, so that cell also primary cell, mercury cell. Secondary cell means less storage battery or nickel cadmium cell. Like many of your houses where you are staying in, like flats or in something, you see big battery DGs are there. Okay, or if you have inverter in your home. Okay, if you have inverter, nowadays e-rickshaw is there or rickshaw is there. So EVs using this kind of batteries, lead storage battery. Okay, so that is what they are chargeable. If you have inverter in your home, they are using lead storage battery. What are the difference actually? Primary battery, see whatever using in your remote TV remote, that is nothing but this primary battery, dry cell, that is also known as Lakeland cell. Okay, dry cell or Lakeland cell. How it is look like inside that battery? What is that inside? Have you ever opened it? Have you ever tried to open it? No. Okay, so if you open ever, don't like use gloves and all. Okay, so when you open it, you will see this is zinc outside layer. This is a zinc cup is there. Whatever the outside layer, that is zinc cup. Inside magnesium dioxide is there, carbon black, and NH4Cl paste is there. Here, it's mixed up of NH4Cl paste, and in the bit in between, carbon rod is there. Okay, so this carbon rod will find out the electricity, and here in the anode side, remember question will ask that in dry cell what reaction going on anode and what reaction going in cathode. So in anode, zinc oxidation, and in cathode what happen? MnO2 will become MnOH. So addition of OH means that is reduction. Okay, or addition of H plus, that is means reduction, or remove addition of electron, air removal of electron. So reactions you need to remember. And what are the electrolyte we are using here? NH4Cl and zinc chloride. Okay, NH4Cl and zinc chloride. How much voltage is there? 1.5 volt. Very small voltage is there. We don't need because your home voltage is 220 volt. We can't go with that. Okay, very small. Sometimes many batteries use for 2.2 volts written. Okay, so 1.5 2.2 volts we can. So you used to commonly use in transistor. Transistor means your TV remote. Okay, TV remote or AC remote. Okay, and the clocks that we are using there. Okay, next is mercury cell. What is mercury cell? Same like that, but this you saw, this kind of cell you saw, right? Button type of cell. Yes or no? This is broken from in small type of batteries. Okay, use like magnets we are using in many toys. It having, yes or no? Have you saw this? Many toys, small toys. It is having. Okay, this kind of battery. Okay, so this mercury cell anode we are using zinc Hg amalgam. Okay, anode we are using amalgam. This amalgam in places of becomes zinc oxide, and cathode we are using mercury oxide, it will become mercury. That's why they told when it is over now, you have to keep it inside the keep it downside, or you have to bury it. Okay, bury it in the ground because it is removing mercury. That is not good for our health. Okay, so you have to bury it in ground. Okay, clear or not? And why you can't recharge it? Because it is a chemical reaction. You can't go back, right? Yes or no? Cell potential 1.35 volt. Okay, we use in low current devices like hearing as watches. Many watch. many watch having this kind of cell. You saw this cell. If I show you, you know, you will say, sir, I saw this cell. Wait. Haven't you saw this kind of cells? Huh? This kind of cells in watches. This kind of cell you saw this kind of cell. Okay. So this is nothing but, so when you use it, after that don't don't throw it in here and there. You have to bury it. Okay, because it is removing mercury. It's complete made up of mercury. Okay. Next storage battery. These are secondary battery. This is used in your inverter home. If you have no inverter in your home, inside that it is there. What is there? There are, this is anode, cathode, anode, cathode, anode, cathode. They are made up of and in series they are. Okay, so what is in anode? Lead is there and sulfate. It is the electrolyte. It is converted into lead sulfate. Okay, Pb2, Pb2 plus. And in cathode, what happened? Pb plus 4 become Pb plus 2. Okay, cathode become Pb plus 4 to Pb plus 2. So PbO2 to PbSO4. Okay, what solution we are using? 38% H2O. 38% H2SO. That's why when inverter batteries are there, you should not cut it, because 38% H2SO4 solution is there. It's corrosive. Okay, inside that. So this the reaction, overall reaction is there. We use in automobile inverter. Okay, now nowadays many EVs are there. Nothing. This is using more advanced version. Okay, not that much big, smaller version, but using we are using this. Okay, so what you have to remember for when they ask its reaction. Yes, they ask. Okay, they will give write about late storage battery. What you have to remember, just anode reaction, cathode reaction, overall reaction. Okay, four batteries are there only. You have in your syllabus four batteries and nickel cadmium cell. Nickel cadmium cell. This is also looks like dry cell, but actually not dry cell. Okay, you can recharge it. Okay, this also you saw. This also you saw, I think. I think so. If you have enthusiasm in science, I think you saw. This, have you saw this? What? Have you saw this? Yes, sir. Yes or no? This you saw. This is nickel cadmium battery. You can recharge it. Okay, 2 volt battery. Understood? Yes, sir. There or not? So this is nickel cadmium battery. So what you have to use here? Overall reaction is cadmium is there. This is cadmium is there, and cadmium become cadmium oxide. Okay. So let's do some questions. Then we will end. Well, when a lead storage battery is charged, it acts as, when it is charged, it will act as, well, lead storage battery is charged. So charged means it will act as what? Electrolytic cell. It will give sorry, it will act as galvanic cell. Yeah, it will give electricity. Reaction is giving electricity. Next, this fuel cell actually it is not there. But remember, fuel cell means hydrogen oxygen cell. We used in aircrafts. Okay, we use in rockets. Okay, jets. We use this. Okay, Apollo space program in space shuttle. We use this kind of batteries. What happened? Nothing. Oxygen in cathode, oxygen is reduced, and anode hydrogen is oxidized. That's it. Overall reaction, hydrogen plus oxygen become water. Okay, so lead storage battery 1.23 volt it is giving. Understood? Simple. Yes. So tell which of the following statement is false about false. They are more efficient. They are free from pollution. They run until reactant are active. Fuel is burned with oxygen. No, burning is not there, right? Burning is not there. Yes or no? We are not burning the fuel, hydrogen fuel. Last, corrosion. Already you learned this in grade 10 also. Corrosion is what? That spontaneous slow oxidation. Okay, spontaneous slow slow but spontaneous oxidation of metal. Okay, mainly we are focusing here corrosion of iron. Okay, what happened? Corrosion of iron in presence of water and air. Three reactions are there that you need to remember. What are the reaction in this? Just reactions are in anode iron become Fe2 plus. In cathode oxygen and H plus become water. Then when overall reaction is this Fe2 plus. Fe2 plus means Fe2O3. Fe2O3. This Fe2O3 when react with XH2 will become Fe2O3 dot XH2. Fe2O3 dot XH2. This is nothing but rust. Okay, this four reaction you need to remember. Okay, so in rusting, what is the reaction? How to prevent rust? That also you know. Process of acceleration rust, you know. Okay, that if salt is there or acidic pH, like here, you know, we all are staying in coastal area. Okay, so in coastal area, gets rusting first because in air or in water, pH value is high, like pH value is low because salts are there. Okay, acidic pH is there. Salts are more are there. Next, contact with metal will difficult oxidize than on stress. You saw you have cycle or bike you have. Okay, it made up of metal. Where you see where if the metal is broken, that place particularly corrode first. Rusting happened in that place first. Okay, so that enhances the corrosion. How to prevent? There are three type of in your syllabus in NCERT. One is called this is this this two this three is called barrier protection. Either you give oil or grease or you can paint. Okay, but problem is there. What is the problem? Problem is there after grease gone or paint gone, again rusting happen. Okay, like in your cycle chain, you give oil or grease. Okay, regular wise you have to give, otherwise it will get rusted. Next, or else you can prevent by sacrificial electrode. Okay, another electrode you add, it will connect to another reactive electrode, and it will it will take all the corrosion. So iron will not corrode. So what happens when metal iron rod or metal rod going through the downside of the ground? Okay, so it can get corroded because downside water is there, oxygen is there. So what do we do? We will add it with another reactive metal that is known as cathodic protection, or you can do galvanization. All of you, both of you know what is galvanization: zinc coating over iron layer. Okay, so after breaking of the zinc coating, iron will not get corroded. Why? Because you know in reactivity series, zinc is more reactive than iron. Yes or no? Zebra, don't call me cute zebra. I like to calling her. Okay, so zinc, zinc is more reactive. So zinc will react with oxygen, not iron. Understood? Till galvanization applying, this is no easy. Zinc only. Next, identify correct statement. Go ahead. Tell.
Sir, option C.
Option C, corrosion of iron is minimized by forming impermeable barrier at its surface. No. Okay. So what do we learn? Conductive titration is not there. Batteries we learn. Okay, titration is not there for you. Okay, for both titration is not there. Okay, clear? About batteries we learned about all the lambda m values, all we learned. So complete electrochemistry is completed. Okay, I'll send some question. Practice that question. They that all of the questions, all of the questions are actually your boards based questions, long questions. How to write that question? I'll send the answers also. We'll discuss the answers. Okay, so very important that thing. Clear? So next day I'll ask. Next class will be on Wednesday morning. Okay, I'll tell you the timing. Next class will be on Wednesday morning. Clear? And next, huh? Sorry, test next week you will be there. I'll tell. Okay, so go through all these two chapters and questions. Okay, and I'm assuming you questions will come from whatever I gave in your classes as well as in the practice sets. Okay.
Yes, sir.
Okay then. Bye. Have a nice day.
Thank you.